At the end of the notes on the previous video, I ended on this slide where I introduced enthalpy, which is going to be represented by a capital H. The definition of enthalpy is the heat content of a system at constant pressure. And in order to calculate the enthalpy of a reaction, which is called delta H, then you would take the H of the products, the enthalpy of the products, and subtract the enthalpy of the reactants. We will go through this in more detail next year in DP. For now, just know it's the heat constant of a system. It's going to have similar units to Q, but it's going to be per mole. Something else that you do need to know is that if a reaction is exothermic, then that means that heat is released and you'll have a negative value of delta H. If a reaction is endothermic, then that means heat is being absorbed, which means you'll have a positive value of delta H. So moving on to the next section of notes, which you should have copied already. We have 16.3 thermochemical equations. So a thermochemical equation is going to be a balanced chemical equation. It's going to include all the physical states and the energy change, which is known as delta H of enthalpy. So this right here is supposed to be a triangle delta, not a capital D. So I'll edit that, but it's supposed to be a triangle like this. So delta H, which is the enthalpy. So this is a balanced equation, water, solid, which it would be like ice converting into liquid water, melting. And the delta H value for that process is a positive 6.01 kilojoules. Notice it's a positive value. Positive values, as stated in the previous slide, are endothermic. If the liquid water, this is an L by the way, okay, those are L's for liquid. If there's liquid water and it evaporates into a gas, then the delta H value for that is 40.7 kilojoules. Again, also a positive value. Both of these processes are endothermic. They both absorb heat for this to happen. So for ice to melt into liquid water, it absorbs heat. And for the liquid water to turn into water vapor, it also absorbs heat. So VAP represents liquid vaporizing to gas, and FUS stands for fusion, which it represents solid melting into liquid. And again, both of these values are positive because these are endothermic processes. If you were to go in the opposite direction, then gas would be condensing to liquid, and so that's how you represent it. Delta H of condensation, COND, stands for condensing or condensation. Or if you took a liquid and you freezed it and you put it in the solid and it froze to solid, then the values again of delta H, this is supposed to be a Greek letter delta, would be negative because those are exothermic processes. So this is how you would represent solidification, delta H of solid. So both of these are going to be negative values, and that's going to be because these processes are exothermic, which means that they release heat. Okay, last section, we have 16.5, which is reaction spontaneity. So a spontaneous process is a physical or chemical process that occurs with no outside influence. In other words, it just happens all on its own. You don't have to apply pressure or heat or anything. It just happens on its own. So that's a spontaneous process. And another term that you need to be familiar with is called entropy, which is capital S. And this is a measure of the disorder or randomness of particles in a system. So if you think about particles and their disorder, a solid substance is going to have a lot of order because they are going to be, the particles are going to be very stable and organized. and they're not going to move. In a liquid, they're going to have more disorder because the particles are going to move a little bit as they move around in the liquid solution. And a gas would have the most disorder because the particles are moving all over the place. So if we look at these drawings, which we've done before, you see that in the solid, the particles are going to stay close to each other. There's going to be most order, which means it's going to have a low S, a low entropy. In a liquid, the particles are flowing and moving. So in a liquid, there is going to be less order than in the solid. And then the gas particles, I drew little arrows representing that they're moving all over the place in random directions. They're going to have the least amount of disorder, aka the most amount of disorder. So they're going to have the highest entropy. So you can predict entropy changes by thinking about the process that's happening, which we just discussed. And if there's a phase change, for example, a solid melting to a liquid or a liquid evaporating to a gas, both of those are going to have entropies that are going to increase. The disorder is going to increase in that direction. If you're going in the opposite direction, a gas condensing to a liquid or a liquid solidifying, then those are going to have entropies that are going to decrease because the order is going to increase. Okay, and then we have one final reaction equation that you guys have to use. One final equation, not reaction, one final equation you guys have to use for this unit. And it's how to calculate free energy, which is going to be represented by capital G. And that is due to the fact that it's actually called Gibbs free energy. That's why we use a capital G. It's energy that's available to do work. And we are going to use this equation. So delta G equals delta H minus T times delta S. That is the equation, which is given to you. You don't have to memorize it. The tricky part about this equation is that you have to remember your order of operations, and you don't just go in order. You have to actually do the multiplication here first, T, the temperature, multiplied by delta S, and then you're going to take delta H and subtract that value. So you just have to be careful with your with your order of operations. Once you calculate this value, then you're going to be able to use this little table to decide or to determine if a reaction is spontaneous or non-spontaneous. So you're just going to line it up. If you end up with a negative delta G and a positive delta S right here, then you're going to be able to come to the conclusion that it's a spontaneous reaction. If you calculate a positive delta G and you have a negative delta S, then you can conclude that it's a non-spontaneous reaction. And if for some reason you had both positive or both negative, then you would not be able to determine the spontaneity based on this table. You would have to look at the temperature values, and we'll talk more about that in DP. For now, you will have either spontaneous or non-spontaneous reactions. Very clear. So here's the example, and you should have left some space in your notes. This is the last thing you wrote. So this is where you're going to do this example. So we want to calculate delta G, and we are given these three values. We are given the temperature and the delta H and the delta S. So since you have these three values, all you have to do is plug them into the formula. So here's what they're asking us to do, calculate delta G. Here is the three pieces of information that they give us. Notice that the Kelvin units match and the joules units match, so this is good. Nothing is not, if we had kilojoules, we'd have to do a conversion, or if we had Celsius, we'd have to do a conversion, but all the units are matching fine, so we can continue. Here's our formula. So you write the formula and then you just plug in the values. So delta G equals delta H, here's delta H, 145,000 joules, minus T. Now I'm putting all this in, notice I put it in brackets because I have to do that first because of PEMDAS. So I'm gonna have to do this multiplication first. The T value is 382 Kelvin, and the delta S value is negative 322 joules over Kelvin. So I'm gonna do this part first. So also I want you to notice that the kelvins are going to cancel. See, this Kelvin is in the denominator. And so this Kelvin and this Kelvin cancel. And now all we have left is joules. So we multiply these two numbers and we get negative 123,004 joules. Bring down everything else. Bring down your 145,000 joules and your subtraction sign. This is where students will sometimes make mistakes. And now you see a negative and a negative right next to each other. Subtracting a negative value is the same as adding. So this is where your algebra skills and your arithmetic skills and all the rules about negatives, those are very important. If you don't remember, these two numbers are going to give you a negative, and subtracting a negative is going to cancel out to a positive. So you end up with 145,000 joules plus 123,004 joules. These joules do not cancel. You're adding them together. It's like saying 5 apples plus 7 apples. It's joules plus joules. So you have 268,004 joules. And that is your answer for delta G. So you calculated delta G. It's a positive value, okay? The delta G is positive, the one you just calculated. The delta S that was given in the problem is negative. So positive delta G, negative delta S. You go to your table. Positive delta G, negative delta S means it is a non-spontaneous process. So the answer there at the end, you calculated delta G, and based on that information, you're able to conclude that this is a non-spontaneous process. And that's how you use the delta G formula.